Good day, friends. You are welcome to Royal Learning Channel. Today we are going to discuss about oxidation and reduction reaction. Oxidation and reduction reaction. In today's class, you are going to learn how to recognize a substance that oxidized and a substance that reduced in a chemical reaction. You will learn a substance that a reducing agent, a substance that is a reducing agent, and a substance that is an oxidizing agent in a chemical reaction. Then you are going to learn how to calculate the oxidation number of an element or an atom in a compound. You learn how to calculate the oxidation of an atom in a compound or in an ion. So let's look at definition of oxidation and reduction. Then oxidation and reduction reaction is also known as redox reaction. Redox reaction. Then what is redox reaction? Is the process whereby oxidation and reduction occur simultaneously in a chemical reaction. Is the process whereby oxidation and reduction occur simultaneously in a chemical reaction. So I'm going to give you 4 definitions of oxidation and reduction. I'm going to give you 4 definitions of oxidation and reduction, and we are going to explain with chemical reaction. Number one definition of oxidation and reduction. So we are going to define oxidation and reduction in terms of oxygen. Then what is oxidation and reduction in terms of oxygen? Now, in terms of oxygen, oxidation is the addition of oxygen, while reduction is the removal of oxygen. Oxidation is the addition of oxygen, while reduction is the removal of oxygen from an oxygen containing compound. So let's explain this term with a chemical reaction. Let's look at reaction between copper oxide and hydrogen gas. The reaction between copper oxide and hydrogen gas will give us copper and water molecule. How did I arrive at this product? This substance will decompose to copper and oxygen. Then we have hydrogen here. Now copper is what? Is a positive ion. It carries +2. Oxygen is a negative ion. It carries what? -1. Then hydrogen is what? Is a positive ion. Then to form what? A compound. You combine what? A positive with what? We combine a positive with what? Negative ion. So you are going to take positive from the reactant, from one of the reactant particle, then combine with negative from one of the reactant particle. There is positive here, but there is no negative here. It shows that our first product will be what? With copper, because copper will not come. There is no negative ion for copper to combine with at this side. Now oxygen here will combine with positive ion at this side to give us what? H2O. So to neutralize the what? The two charges, we add 2. +2 -2 will give us 0. So oxygen will combine with hydrogen to give us what? Water molecule. That is the formation of the product. Now let's come back to this definition of oxidation and reduction. Let's come back to the definition of oxidation and reduction. Now we are going to combine one of the reactant side with one of the product side having something in common. We combine one of the substance at the reactant side with the one at the product side having something in common. Now let's look at copper oxide. Then with copper, we can combine copper oxide with copper because there is copper here, then we have copper here. So let's combine copper oxide and copper. Now water, the hydrogen and what? And water molecule. So there is hydrogen here, so they have something in common. So we combine them together. So which one oxidize now? Which one undergo oxidation reaction? Then which one undergo reduction reaction? Now let's come back to the definition. Oxidation is the what? Is the addition of oxygen. Oxidation is the addition of oxygen, while reduction is what? Is the removal of oxygen. Let's look at it from copper oxide to copper. From copper oxide to copper. Oxygen atom is being removed from copper. Oxygen atom is being removed from copper to give what? Copper oxide. So therefore, this is removal from oxygen atom, from copper oxide to copper. There's removal of oxygen, and removal of oxygen is called what? Reduction. So this one is reduction. This one is reduction. Then from hydrogen gas to water molecule, there is addition of oxygen to hydrogen gas to give us what? Water molecule. And addition of oxygen is called what? Oxidation. So addition of oxygen is called oxidation. So it shows that copper what? Copper oxide reduced to give us what? Copper. Then while hydrogen oxidized to give us water molecule. Now, which one is an oxidizing agent now from our reactant particle? So which one is an oxidizing agent? Which one is the reducing agent? So the one that undergo what? Reduction is copper that undergo reduction reaction. So copper is what? Is an oxidizing agent. So the substance that undergo reduction is what? Is an oxidizing agent. So therefore, copper oxide is what? Is an oxidizing agent. OA means oxidizing agent. Then why the substance that's reduced is what? Is now the reducing agent, the opposite. So the one that reduced is the one that reduced is the oxidizing agent, while the one that oxidized is the reducing agent. So hydrogen undergo what? Oxidation reaction. Hydrogen undergo oxidation reaction. Therefore, hydrogen is what? Is a reducing agent. Hydrogen is a reducing agent. So that is how to recognize a substance that oxidized and a substance that reduced. Then a substance that undergo an oxidizing agent and the one that undergo what? A reducing agent. So a substance that undergoes oxidation reaction is what? Is a reducing agent, while the one that undergo reduction reaction is an oxidizing agent. So let's take another example. Reaction between copper and oxygen will give us reaction between calcium and oxygen will give us calcium oxide. Calcium oxide. Then what will be our oxidizing agent? Then which one is our reducing agent? Now, from calcium to what? To calcium oxide. So what happened from calcium to calcium oxide? Then oxygen is added. Oxygen is being added to calcium to give us what? Calcium oxide. Then addition of oxygen is what? Is oxidation. Addition of oxygen is what? Is oxidation. Therefore, calcium is what? Is a reducing agent. So calcium undergo oxidation reaction. It oxidized to calcium oxide. So therefore, the one that undergo oxidation reaction is what? Is a reducing agent. So calcium is a reducing agent, but it oxidized to calcium oxide. It oxidized to calcium oxide. Now let's move to the second definition of oxidation and reduction. So let's define oxidation and reduction in terms of hydrogen. In terms of hydrogen. In terms of hydrogen. Now, in terms of hydrogen, what is oxidation? Oxidation is the removal of hydrogen, while reduction while reduction is the addition of hydrogen. So oxidation in terms of hydrogen, oxidation is the removal of hydrogen from hydrogen containing compound, while reduction is the addition of hydrogen. So let's look at this. Let's use this chemical reaction to explain oxidation and reduction. So reaction between hydrogen sulfide and chlorine molecule. Reaction between hydrogen sulfide and chlorine molecule will give us what? Now let's form our products. Hydrogen is a positive ion, sulfur is a negative ion. Then chlorine is what? Is a negative ion. So positive here we combine with what? With negative to give us HCl. Then we have used hydrogen and chlorine, so we are left with what? Sulfur. So sulfur will be deposited. In form of solid. So which means that reaction between hydrogen sulfide and chlorine will give us sulfur and what? Hydrogen chloride gas. Sulfur and hydrogen chloride gas. So to balance our equation, we have 2 hydrogen here, 2 chlorine here. So we are going to put 2 here to balance what? The number of hydrogen and chlorine atom at the product site. Now let's come back to this definition now. In terms of hydrogen, oxidation is the removal of hydrogen. Now we are going to combine substance that's having something in common at the reactant side and the product side. Combine substances having something in common. Now we have hydrogen sulfide here, there is sulfur here. So we can combine hydrogen sulfide with sulfur. Then we combine chlorine with hydrogen chloride gas. Then we go back to the definition. Removal of hydrogen is oxidation. Now let's look at this place. From hydrogen sulfide to sulfur. Hydrogen atom is being removed to give us what? Sulfur. So therefore, removal of hydrogen, we remove hydrogen from hydrogen sulfide to give us what? Sulfur. So therefore, removal of hydrogen is what? Is oxidation. So this one undergo oxidation reaction. Now from chlorine to hydrogen chloride. So hydrogen is being added to chlorine to give us hydrogen chloride. Therefore, this one undergo what? Reduction. That is, reduction is addition of hydrogen. Now, which substance is now an oxidizing agent? Which one is the reducing agent? Don't forget that I said that the substance that undergo oxidation is what? Is a reducing agent, while the substance that undergo reduction is what? Is an oxidizing agent. So the substance that undergo oxidation, hydrogen sulfide undergo oxidation reaction, therefore it is a reducing agent. While chlorine undergo what? Reduction. The chlorine undergoes what? Reduction reaction. So therefore, the substance that undergoes what? Reduction reaction is what? Is an oxidizing agent. So chlorine is an oxidizing agent. So let's move to number 3. This is number 2. Then let's define in terms of electron transfer. in terms of electron transfer. So I'm going to use what we call oil rig to explain oxidation and reduction in terms of electron transfer. I will use oil rig. So oil is for oxidation, while rig is for reduction. Oil is for oxidation, rig is for reduction. Then O is oxidation, I is, then L is loss. So oxidation is loss of electron. Oxidation is loss of electron from that oil. Oxidation, O stands for oxidation, I stands for is, then L stands for what? Loss. So therefore, oxidation is loss of electron or electrons. So while reduction from rig, R is reduction, I is S, G is gain. So reduction is gain of electrons. Is gains of electron. So oxidation is what? Is loss of electron, while reduction is what? Is gains of electron. So let's explain this with chemical reaction. Let's explain with chemical reaction. Let's look at reaction between magnesium and sulfur. So when magnesium reacts with sulfur, it will give us magnesium sulfide. Magnesium sulfide. So which one undergo oxidation reaction, then which one undergo reduction reaction? Now, those one with positive ion, they usually what? Give out their electron. They usually give out electron. So which leads to what? Loss of electron. Why those one with what? An atom with negative ion, they usually gain electron. So they are electron acceptor. So which leads to what? Gaining of electron. So which means that all positive ions donate electron. So which leads to loss of electron. While negative ions what? Accept electron, which leads to what? Negative ions. Now let's come to magnesium. Magnesium is a number 12. Magnesium is a number 12. So if you want to draw the electronic shell of magnesium, number 12, the electronic shell of magnesium, the first shell will carry 2 electrons. Don't forget that according to our electron distribution, the first shell, which is known as K shell, will carry the maximum number of 2 electrons, while LMNOPQ carries what? The maximum number of 8 electrons. Now out of 12 electrons, so the first shell will carry 2, then the second will carry 8. Then 2 plus 8 will give us 10. Then the last shell will now carry 2 electrons. It carries 2 electrons. Now those elements with 1, 2 or 3 valence electron are donor. They do give out electron. So there will be loss of electrons. So those elements with 1, 2, 3 valence electron are donor. They used to give out electron, which leads to what? Loss of electron. Then they are all metallic ions, so they are positively charged. So they donate out electron at the outermost shell to become what? Positively charged. Now, let's look at this one. This magnesium is having 2 electrons. It is having 2 electrons. So therefore, it will donate out these 2 electrons to become what? Magnesium ion, Mg2+. This 2+ means that it has donated these 2 electrons at what? At its outermost shell. So the shell will now reduce to what? 2, 8. 2, 8. So the shell will reduce to 2, 8. So magnesium now will now turn to what? This is magnesium atom. So it will become what? Magnesium ion. So this one it has what? 2 negative, it has 2 what? 2 positive electrons, 2 electrons, which is called proton. Now, let's look at sulfur. Sulfur is in number 16. Now, the first shell, we carry 2. The second, we carry 8. Then, while the third one, we carry what? 6. Now, this outermost shell needs what? 2 more electrons to complete that 8. It needs 2 more electrons to complete that 8. Now, those elements with 5, 6, and 7 electrons, they are what? They are electron acceptor. They always accept electron from positive ion to complete what? Their outermost shell. So those elements with 5, 6, 7th valence electron, they are electron acceptors. So they will accept more electron to complete their outermost shell, and they are what? They are negatively charged. Now, this sulfur atom will become what? Sulfur ion. By the time it gains what? 2 more electrons. So it will now collect these 2 electrons from what? From magnesium. So it will collect 2 electrons from magnesium. So these 2 electrons will come to the shell. So we come to the outermost shell of magnesium to become 2, 8, 8. Now, these 2 electrons will enter here. So these 2 electrons, they are from what? The 2 electrons are from magnesium. Now, the sulfur will now become what? What we call sulfur ion. That's 2 minor, because it has accepted 2 electrons from magnesium ion. So this one we what? We give out electron, which leads to loss of electron. So loss of electron is oxidation. Now, from magnesium to magnesium what? Sulfide. So magnesium will give out what? 2 electrons to sulfur, which leads to what? Loss of electron. So loss of electron is what? Is oxidation. Then from sulfur to magnesium sulfide, that is, the sulfur collected 2 what? 2 electrons from magnesium to become magnesium sulfide, which leads to what? Gaining of electron from sulfur. So which is what? Reduction. So oxidation is what? Gaining of, oxidation is loss of electron, while reduction is what? Is gaining of electron. Then how will you recognize a substance that oxidizes in terms of loss or gain of electron? So the positive ion will what? Will lose electron, will give out electron. Then while the negative ion will what? Will gain electron. The positive ion, they are what? They are electron donor, which leads to what? Loss of electron. While the positive ion, they are electron acceptor, which usually what? Leads to what? Gaining of electron. Gaining of electron. So the last one is definition of oxidation and reduction in terms of oxidation number. Number 4. In terms of oxidation number. In terms of oxidation number. In terms of oxidation number, what is oxidation? Oxidation is increase in oxidation number. Increase in oxidation number. Oxidation is what? Is increase in oxidation number. So while reduction is decrease in oxidation number. So oxidation is what? Is increase in oxidation number, and reduction is what? Is decrease in oxidation number. So under this oxidation number, you must be able to calculate the oxidation number of an element in a compound. You must be able to calculate the oxidation number of an element in a compound. Then the oxidation number of a free atom or molecule is usually equal to 0. Take note. Note the oxidation number of a free atom or molecule is equal to 0. Is equal to 0. That is, the oxidation number of a free atom or molecule is equal to 0. Then what is an atom? A free atom, that is a monoatomic element. So a free atom is a monoatomic element, like all metals. All metals are monoatomic. Then the atoms of noble gases are what? Are monoatomic. That is, the group O elements are monoatomic. So the oxidation number of what? Of all metallic atoms and what? And noble gases are what? The oxidation number of monoatomic substance, that is metallic atom and noble gases, is equal to 0. Oxidation number of all metallic atoms and noble gases is equal to 0. Then let's talk about molecule now. Molecule is the combination of what? Of two or more non-metallic atoms. Combination of two or more non-metallic atoms. So oxidation number of what? Of any molecule in what? In oxidation and reduction reaction is equal to 0. So example of a molecule is carbon 4 oxide. How will you recognize a molecule? It consists of, or the combination of what? In two or three non-metallic atoms. That is combination of 2 or 3 non-metallic. So carbon is what? Is not a metal. So oxygen is what? Is a non-metal. So combination of 2 non-metallic atoms will give you molecule. Now, let's come back to calculation on oxidation and reduction. Then I'm going to use equation of the reaction, a chemical reaction, to explain this oxidation number. Now, let's take reaction between iron 2 chloride and chlorine molecule. We give us iron 3 chloride. So let's combine the substance having something in common. Now, iron 2 chloride with iron 3 chloride, then chlorine with what? With iron 3 chloride. Now, we call this one iron 2 chloride. That is, we calculate the oxidation number of all the elements in this what? In this compound. let's calculate the oxidation number of all the elements in this compound. Let's start with iron. So what is the oxidation number of iron? Iron is unknown. Then the charge on chlorine. What is the charge on chlorine? Chlorine is the number 17. That's 2:8:7. So it needs one more to balance. So the charge on chlorine will be minus. So minus 1 times 2 will give me minus 2. Will give me minus 2. So equal to what? Equal to 0. So F equal to, bring minus 2 down here, will give you plus 2. So the number of charge or oxidation number of what? Of iron is what? Is plus 2. So iron is plus 2 at this side. Then chlorine will now be what? Be minus 2, because it's plus 2 that will carry to what? Minus 2. Then the charge on chlorine is minus 1. Minus 1 times 2 will give me minus 2. So the oxidation number of iron in this compound is plus 2. Then the oxidation number of chlorine is minus 2. Now let's come to this place. Cl2 is a molecule. Cl2 is a molecule. That is 2 atoms of what? Of non-metal. Chlorine, 2 what? 2 atoms of chlorine. Then chlorine is what? Is a non-metal. Chlorine is a non-metal. So 2 or more atoms of a non-metallic element is what? Is a molecule. So oxidation number of a free atom or molecule equal to 0. So therefore the oxidation number of this chlorine molecule is what? Equal to 0. Now let's come back to this place. Let's come back to this place. We want to calculate the oxidation number of iron and chlorine from our product side. So we make iron unknown. So Fe is an unknown now. Then the charge on chlorine is minus 1. Minus 1 times 3 will give me minus 3 equal to 0. So therefore, Fe equal to, bring minus 3 down here, will give you plus 3. So the oxidation number of what? Of iron in this compound is plus 3. So plus 3. Therefore, that of chlorine will be minus 3, because chlorine is minus 1. Minus 1 times 3 will give me minus 3. So chlorine is minus 3. Now let's compare. Let's compare what we have at the reactant side and what we have at the product side. Then what do we have in common at this side and at this side? We have iron here. There is what? There is iron here. Now, let's look at this one. We call this one iron 2, because the oxidation number of this iron here is what? Is plus 2. So from plus 2 to plus 3. Iron is plus 3 here. So from plus 2 to plus 3, there is increase in what? In oxidation number. That is, iron increase from plus 2 to plus 3. Then oxidation is what? Increase in oxidation number. From iron 2 to iron 3 now is what? Is oxidation. Because there is increase from plus 2 to plus 3. This oxidation. Now, let's look at from chlorine to chlorine ion at this side. Chlorine is an ion at this side. So chlorine is 0 at this side. Then chlorine is minus 3 at this side. So 0 is more than minus 3. So there is what? Decrease in oxidation number. There is decrease in oxidation number. So it reduces from what? From 0 to minus 3. Therefore, this is what? Reduction. This is reduction. Then don't forget that iron 2 is the one that oxidized now. Iron 2 oxidized. Therefore, iron 2 is what? Is a reducing agent. The substance that oxidized is what? Is a reducing agent. While the substance that reduced is what? Is an oxidizing agent. So chlorine reduced to what? To minus 3. So therefore, chlorine is what? Is an oxidizing agent. Chlorine is an oxidizing agent. That is what? In terms of oxidation number. In terms of oxidation number. So let's move to how to calculate the oxidation number of an element in a compound. Calculation on oxidation number of an element in a compound. So number 1, calculate the oxidation number of 1 chlorine, that is Cl, in KClO3. 2, oxidation number of Mn in MnO minus. Then 3, MnO4. Let's use MnO4. Then number 3, oxidation number of chromium in K2Cr2O7. 4, oxidation number of chromium in Cr2O7 minus. Then 5, oxidation number of chlorine in CaClO3 2. So we are going to look for the oxidation number of each of the following elements in their compound. We want to look for the oxidation number of each of the following elements in their compounds. So let's look at number 1. Number 1. So we are looking for the oxidation number of chlorine in KClO3. So from this compound, we are looking for the oxidation number of chlorine. So we make chlorine the subject of the formula. Then what is the charge on potassium? Potassium is a number. So let's break what we have here down. So we have K, we have Cl, then we have O3. We have K, 1K, 1Cl, then 1O3. Now, what is the oxidation number of potassium, or the charge on potassium? Potassium is in number 19. So in ratio form, the electronic configuration in ratio form will be 2, 8, 8, 1. Then don't forget that I told you that the oxidation number of elements having 1, 2, or 3 valence electron is the number of their valence electron. So they are positively charged. That is that the number of their what valence electron will determine the number of what of the charge on them. Now this one is having 1 valence electron, so therefore the charge on potassium will be +1, which is written as plus. Now the oxidation number of chlorine is in number 17. So if you write the electron configuration ratio form, that will be 2:8:7. So this last shell needs 1 more to balance, to complete that 8. Therefore, the oxidation number or the charge on chlorine will be minus. Now, we are not looking for chlorine. Chlorine is our unknown. So we are not going to calculate the oxidation number of chlorine since we are looking for chlorine. So let's leave chlorine. Then let's come to oxygen. Oxygen is in number 8. So in ratio form, the electronic configuration will be 2:6. So it needs 2 to balance that 8. The charge on oxygen will be 2 minus. Now let's go now. Now from here, the charge on potassium is 1 plus 1. Now plus 1 times 1 potassium will give us +1. Then plus chlorine. We are looking for chlorine. Then the charge on oxygen is -2. -2 times 3 will give us -6. Then everything equal to 0. Now +1 minus 6. +1 minus 6 will give us -5 equal to 0. So therefore Cl equal to, bring this -5 to this side, we change to +5. So the oxidation number of chlorine The oxidation number of chlorine in this compound is what? Is plus 5. Is plus 5. Now let's move to number 2. Number 2. We are looking for the oxidation number of manganese, that's Mn, in MnO4 minus. In MnO4 minus. Now, let's break down what we have here. Let's break down what we have here. So from this side, we have 1 manganese, then we have 4 oxygen. 4 oxygen. Then the charge on it will come to the front of equal to -1. That is, the charge, this charge will come to the front of equal to, that is -1. Minus means -1. Now, we are looking for the oxidation number of what? Of manganese, which is Mn. So Mn is our unknown. So Mn. Now, what is the charge on oxygen? Is 2 minus. So -2 times 4 will give me -8, equal to -1. That is this charge, -1. Now, Mn will now be equal to, manganese will now be equal to -1. Then bring this -8 to this side, will give you +8. So Mn, manganese, equal to -1 plus 8 will give us +7. So the oxidation number of manganese in what? In MnO4 minus is what? Is +7. Is +7. Now number 3. Oxidation number of Cr, which is chromium, in K2Cr2O7. So chromium in what? In potassium ethyl 7. So let's split what we have here. We have 2 potassium. We have 2 chromium. Then we have what? 7 oxygen. 2 potassium, 2 chromium, 7 oxygen. Everything equal to 0. Since it has no charge. Now, what is the charge on potassium? Is plus. Then we are looking for chromium. Chromium is our unknown, so we are not going to assign any charge. Then the charge on oxygen is 2 minus. The charge on oxygen is 2 minus. Now +1, this plus means +1. +1 times 2 will give us +2. Then plus chromium is 2. Now 2 times chromium will give you 2 chromium. 2 chromium. Then -2 times 7 will give us -14, equal to 0. Now +2 minus 14 will give us 2Cr minus what? -12. +2 minus 14 will give us -12. Then equal to 0. Now 2Cr will now be equal to, bring this -12 down to this side, will give you +12. Then you are looking for chromium. Divide both sides by what? Divide both sides by 2. 2 will cancel 2. Then chromium will now be equal to +6. 2 here 1, 2 here 6, +6. So the oxidation number of what? Of chromium in potassium ethyl 7 is what? Is dichromate 6. So it's dichromate 6. Is 6 +6 +6. Then number 4. Number 4. Number 4. So we look for chromium in dichromate, ethyl 7 ion. We are looking for chromium in ethyl 7 ion. So let's split what we have here. Let's split what we have here. So we have 2 chromium. Then we have 7 oxygen. Then the charge on it will come after equal to. So the charge minus 2 will come to the front of equal to. Now chromium is what we are looking for. So you assign no charge. You assign no charge. Then oxygen, the charge on oxygen is minus 2. So chromium now 2 times chromium will give you 2 chromium. Then minus 2 times 7 will give us minus 14 equal to minus 2. Now 2Cr equal to minus 2. Bring minus 14 to this side will give us plus 14. Then 2Cr equal to minus 2 plus 14 will give us plus 12. So divide both sides by 2. Divide both sides by 2. So chromium will be equal to 2 here 1, 2 here 6 plus 6. So the oxidation number of chromium from ethyl dichromate 6 ion is what? Is plus 6. Is plus 6. Now lastly, number 5. We want to calculate the oxidation number of chlorine from this compound. Oxidation number of chlorine, number 5. Chlorine in Ca into bracket ClO3 2. So let's break down what we have here. Number 1 is calcium. We have calcium. Then we have to open this bracket. Then we use what we have outside the bracket to open what we have inside the bracket. So 2 times chlorine will give us 2 chlorine. Then 2 times 3 oxygen will give us 6 oxygen. So oxygen is 6. Then everything equal to 0 since it has no charge. Now we are looking for what? For chlorine. So chlorine is our unknown. So you assign no charge. You assign no charge to chlorine. So what's the charge on calcium? Calcium is in number 20. So the electronic configuration will be 2, 8, 8, 2. 2 plus 8 plus 8 plus 2 will give us 20. So it has 2 valence electrons. Therefore, the charge is plus 2. So the charge on calcium is plus 2. Then the charge on oxygen is 2 minus. Now, plus 2 times 1 calcium, because we are having 1 calcium, that is plus 2. Then chlorine unknown, 2 times chlorine will give us 2 chlorine. Minus 2 times 6 will give us minus 12 equal to 0. So plus 2 minus 12 will give us 2Cl minus 10. Minus 10 equal to 0. Now 2Cl equal to, bring this minus 10 here, we change to plus 10. Now divide both sides by 2. So chlorine will now be equal to 2 here 1, 2 here 5 will be equal to plus 5. So the oxidation number of chlorine, from this compound is what? Is plus 5.